Hi, my name is Chanel Wu. My pronouns are they, them, and theirs, and today I'll be presenting Unfabricate, an exploration in designing smart textiles for disassembly. So my hope is that this can inspire some people to think not only about smart textiles, but larger ways to design something for disassembly and reusability. So this clip will shows a simple smart textile component. And smart textiles is an emerging field of technology that integrates electronics into textiles, often by weaving them in this case, as shown in this case, or sometimes knitting and other processes into the structure. This video, this shows this simple woven smart textile component similar to a potentiometer with sensing and an LED output directly integrated into the fabric. However, this future technology has this possibility of making two already big problems even worse. So globally, we generate tons of waste, and one major waste stream is e-waste, where we discard devices, electronics. Over 50 million tons per year is generated globally, with the USA alone generating more than 6 million tons per year. And this waste is often shipped to different countries and creating this whole secondary industry and pollution source. On the other side of smart textiles, textile waste is also a large problem. In the USA alone, we generate more than 15 million tons per year of discarded clothing, other textiles, fabric scraps, and so on. So if smart textiles was to become this $5 billion industry in the next 10 years, as some people project, what will smart textile waste look like? Fortunately, to help our answer, we have the wisdom of textiles to draw upon. So the smartness of smart textiles isn't just limited to electronic sensing. In textiles, we have this history of unraveling and reusing objects for materials, such as Depression-era knitters, unraveling and reusing the yarn from garments that their children had outgrown. And we find that these structures of knitting and weaving, because they're not glued together, are really compatible with taking apart. And historically, these processes have informed computing systems, and you can even say that textiles is computing. And so there's an opportunity there to really systematize this kind of disassembly. So to conduct this inquiry, we started actually by going through to the thrift store and finding things that unravel. From there, we started experimenting with knitted and woven structures, eventually just focusing and narrowing down on weaving. And we found that to fabricate that prototype that I showed earlier, we had to adapt existing design tools, finally to create a proof of concept object that we could actually unravel. As I mentioned before, we started at the thrift store. And this was to answer the question, what are existing practices in disassembling textiles? To borrow a term from design anthropology, we called this process sensitization to get a sense for the past and present ways that people disassemble and reuse textiles, a lot of clothing, for materials, where people would actually go to the thrift store, find suitable garments to unravel so that they could use the yarn for other projects. And I think this really connects to other design for disassembly movements in domains such as industrial design and architecture. Like, how can we design our things to be disassemblable, reusable, or more easily recyclable for materials? So a quick overview of what we learned about how to unravel a sweater. So we start with the sweater, and we find that you can, if you look really closely and carefully and learn more about the structure of the garment, you can carefully unpick the seams so that you're not actually cutting the sides. And you can end up actually completely separating the garment pieces. And from there, we unraveled each piece one by one. This actually shows I co-opted a tool that usually is just used to wind up yarn, but I found it really helpful for speeding up the unraveling process. And from there, you wind it into loops, really taking care to not tangle it, then wash it. And then I got this nice usable yarn from a sweater. So from here, we had some lessons and possible design principles for designing a smart textile for disassembly. So the first one is that we wanted to minimize cutting the yarn, and a process like serging cuts the yarn a lot. And if we shape these pieces, we'll have to cut even less, shape the pieces while fabricating them. And two, to support that kind of reverse engineering that really helps a person unraveling maximize their yield, you want to make the steps of fabrication visible. So let's dig more into like what makes a fabric unravelable. As you saw in that sweater, that was in particular a knit, so it's made of interlocking loops of yarn. And if you see at the top of this diagram here, in knitting, say like this is what serging would do. If you cut a knit piece, you'll end up with a lot of short lengths of yarn. But then if you do keep the yarn continuous while you're making it, you can imagine the rows getting wider or narrower, you'll be left with more continuous lengths of yarn. However, in weaving, where you're interlocking two perpendicular sets of yarn, it's way more common, just because that's how the machinery is developed, to make a large rectangle and then cut a shape out of it. So we were interested in ways to modify a woven structure to make it more easy to unravel. So in a series of experiments with a woven structure, we were playing with ways that we could keep both the warp and the weft yarns continuous. As I said before, the warp yarn is the vertical one set of yarn. In this case, it's vertical, and the weft yarn is the horizontal, and usually inserted after the warp setup. So we started with just keeping the weft continuous, but then we saw that we could also keep the warp continuous. Finally, we actually ended up with this structure where we doubled up the warp and ended in loops on each edge of the fabric. And you can see here, if you pulled on the red end of the yarn, like a knitted structure with those interlocking loops, these looped warp yarns could just come straight out.
To lock in the loops so that they would only unravel when we wanted them to, we inserted a key yarn, as this arrow shows. To further make the structure unravelable, we adapted it for shape weaving by introducing a warp tightening method. So we'd first set up the warp normally as a rectangle, but then because the warp is continuous, we could tighten it against the weft to secure the edges of the shape. Besides modifying the actual structure, to scale our ability to create that structure to make a piece large enough to be useful, we also found it useful to modify software, which we also made in our lab, which you can also read that paper after you're done reading this one. And we found that we had to physically modify the tools we were using, these looms. Finally, we had all the pieces necessary to create the component which you saw earlier. These process photos show how weaving is an additive process where you create the design row by row. So here is a photo taken about halfway through the process of creating the circle, which we chose a circle because geometrically it is the hardest shape to create a smooth curve in a process that's traditionally rectilinear. So the photo on the right here shows, now that now that the lines have something to point to. The photo on the right shows how the conductive yarns were easily inserted into the process. As you can see, we insert them like any other yarn, along with the kind of normal ground yarn. So with that, we have a smart textile component. Now, the ultimate test. Is it unravelable?
So in this piece, we see that top yarn was kind of the key, locking in all the loops, and now I am unraveling that looped warp yarn. You can see with some coaxing, you do have to kind of tug it, but it comes out. And once the looped warp is out, then all that weft there is just left for you to roll back up. And again, keeping it from tangling, we are left with just usable lengths of yarn. And I've actually used those little bits of yarn to weave new things or embroider new things. And so we have this proof of concept. It's a piece. So where do we go from here? One concept that would be a good next step is that we can adapt the structure to weave three-dimensional shapes. So if you can imagine setting up the warp in the normal rectangle and you weave a shape with a concave area, then when you take it off the loom and you start tightening up those warps, then you can fold it up into a three-dimensional structure. A second opportunity I think is unique to knitting and weaving and yarn-based processes is that when you unravel them, you get this chance to kind of revisit the yarn, rewind all those processes. And also literally while you're winding them, you have to pass them through your hands or other tools to keep it from tangling. So you could imagine, say, like recoating a worn out yarn, modifying it so that it had a new color or different properties, and so on. And a third concept that I think would be really cool is this idea of modular unraveling. So we've been talking about just unraveling a whole piece and using it for yarn, but as you saw in the sweater process slide, a garment is composed usually of multiple pieces, and if each piece could individually come off and be unraveled, then you can have this modular garment where you are changing the function of a particular component, such as in this case, changing a scarf, a hood, change a pressure sensor to a moisture sensor, so on.
One last sales pitch for designing not just to fabricate, but to unfabricate. We are really great at making things and making machines that are even better at making things faster than we can. So I imagine we could create processes that are also great at taking things apart so that we reduce waste and preserve more materials to make more things. Some values that help me think through taking apart future smart textiles that might be helpful for any future work that this inspires, I found that really tuning into the history of my materials helped the unraveling process. When I unraveled a hand knit garment, I could see the choices that the knitter had made. Unraveling could help us recast materials as objects in themselves, which can evolve and be remade time and time again. And I personally did not have a very automated process. I used my hands, but I also saw many openings to use different tools, software, and hardware that could save me time, suggesting future infrastructure that is a mix of handwork as well as different tools for time saving, as well as automation. This mixed infrastructure could be useful in a variety of settings, from really resource constrained environments such as emergency response to fully industrialized settings. And finally, I found this personal exploration taking me to all of those global contexts, even though it was an incredibly individual set of experiments. Global contexts such as e waste recycling workers who work overseas, which handle the US's e waste after we ship it over there. So, in summary, designing for unraveling and disassembly at large could open up new and intriguing computational challenges. I hope that this presentation inspires you to try out weaving and playing with conductive yarns for smart textiles, or thinking about disassembling and recycling prototype materials. Thanks to my advisor, Laura Devendorf, my colleagues at the Atlas Institute at the University of Colorado Boulder, and of course, every one of my lab mates in the Unstable Design Lab community. You can reach me via email at chanel.wu@colorado.edu. If you're socially medially inclined, Instagram is also the best way to reach me for any sort of professional work.